How's it going? To the video, I'm gonna answering question number 1 from thermodynamic under the chapter of steady flow. Air enter a 16 cm diameter pipe steadily at 200 kPa and 20 degrees C, velocity of 5 meter per second. Let's jump to the problem solving. So we have a pipe at the inlet. The property of the air will be 200 kPa. Temperature itself will be 20 degrees C, equal to 293 Kelvin. We have a velocity given, pressure at the output will be 118 kPa, the temperature will be 14 degrees C at the outlet. So first question is asking about the volume flow rate of the air at the inlet. So essentially there is the formula for the volume flow rate. Mass flow rate in equal to rho in, that refer to density air in the inlet times by the volume flow rate in the inlet. So we don't know what is the density of it and the mass flow rate, so we need to calculate. To get the specific volume or density, we can get from the specific volume, and specific volume we can get from this equation, the gas constant equation. It is only valid if the fluid were 100% were in gas form. Since that in this question the fluid were in the form of air, so we consider this must be in the form of gas. We can use this equation. So in this equation, pressure times by specific volume equal to R, refer to gas constant equation, times by the temperature that respect in the form of Kelvin. So the pressure in the inlet will be 200 kPa. The specific volume, we want to find out the gas constant equation, that will be 0.2870 kilojoule per kg Kelvin. So the temperature, since that we were dealing with a gas constant in the form of Kelvin, we need to transfer the unit into Kelvin. So 293 K. So we calculate the specific volume, we'll get 0.4205 meter cube per kg. We just simplify this equation by power rate -1, so we can get the density. So 0.4205, the power of -1, we will get the density will be 2.3784 in the unit of SI, kilojoule kg per meter cube. So for the mass flow rate we can get from this question. Essentially there is a second question. If you notify how long it will take, this one by the mass flow rate. So the mass flow rate equal to rho VA. Rho in here there will be 2.3784 times by the velocity at the inlet, 5 meter per second, times by the area of the pipe. Since that the diameter of it will be 16 centimeter, you need to convert into meter. Then divide by 2, we'll get pi times by 0.08, the power of 2, we will get 0.0201 in the form of meter square. So we calculate the mass flow rate, there will be 0.2391 kg per second. Now we can finally find out the specific volume, the volume flow rate. We know that the mass flow rate will be 0.2391. We divide it by the density, that will be 2.3784. We will get approximate 2.1005 meter cube per second. So that is the answer for question number 1. Question B, we already discussed it, the mass flow rate of the air. It doesn't matter if you want to make analysis at the inlet or outlet, since that we assume the device were in steady flow, so the mass flow rate will be the same. So in this work step, I'm choosing inlet as my point of analysis. So we'll get 0.2391 kg per second. So that is the mass flow rate. So now See question, the average velocity of the water at the nozzle. No, not this one. But the velocity and volume flow rate at the exit. Assume that the flow was steady. It is mean the mass flow rate in equal to mass flow rate out equal to rho VA, with respect to output. When mass flow rate in equal to 0.2391 kg per second, we don't know what is the rho density of the air at the outlet. We don't know what is the velocity, since that it is the question asking us. We know that the area, since that it share the same diameter of pipe, so we'll have a same area 0.0201 meter square. We can find out the rho by gas constant equation. We get the specific volume. Since that the pressure now will be 180 kPa, we 0.2870 K, that refer to kilo, times by 313.15. This refer to temperature at the outlet respect upon Kelvin over by 118 kPa. So we'll get 0.4993 meter cube per kg. So that is the specific volume. Now we can get the density. We'll get 2.0028 kg per meter cube. So bring this equation downward. We can calculate the velocity, since that we know what is the mass flow rate at the inlet. It will be 0.2391, which is this one, times by the density at the outlet 2.0028, times by velocity times by the area at the outlet 0.0201. You will get the velocity will be 5.9394 approximate meter per second. So the last question, but nonetheless, average velocity, volume flow rate at the exit. You can get it from this equation. Mass flow rate out equal to rho density at the outlet times by the volume flow rate at the outlet. Since that volume flow rate at the outlet we want to find out, so we bring this equation to the left side. So we'll get mass flow rate at the outlet will be 0.2391 divided by the rho of the air at the outlet 2.0028 kg per meter cube. So we'll get the volume flow rate will be approximate upon 0.1194 meter cube per second. So I think that's all for today. Thank you for watching. If you didn't have any advice from me, I'm gladly appreciated. And by the way, I'm attached the PDF answer at the comment section, so you can make a reference later on, because some of the my viewer suggest for me to attach the PDF answer, since that my handwriting in the video has been differed by the quality of it, so they cannot see the answer clearly. So I make attachment for my answer at the comment section. That's all for today. Thank you for watching and have a nice day. Bye bye.